We are back with our washing machine, our posture, and Pythagoras. We are up to the Tetraktys, number as paradigm. The Pythagorean oath is I swear by the discoverer of the Tetraktys, which is the spring of all our wisdom, the perennial fount and root of nature. The Pythagoreans perceived another principle in number in addition to seeing it as a formative agent active in nature. This is perhaps best exemplified in the figure of the Tetraktys, which, as we might say in the present century, stood as a numerical paradigm of whole systems. As we have observed, the Pythagoreans were accustomed to arranging numbers in geometric shapes. And there are a variety of descriptions which have come down to us from antiquity of triangular, square, pentagonal, and other figured numbers and their properties. This way of representing numbers may have well resulted in the discovery of geometrical theorems. Moreover, the observation that the relations between different types of geometrical numbers follow certain definite patterns surely furthered the Pythagorean contention that mathematical study is an important route leading to the perception of universal laws. The most well-known example of such a figured number is the famous Pythagorean Tetraktys, or quaternary, consisting of the first four integers arranged in a triangle of 10 points. So you have 1 at the top, 2 in the next level, 3 in the next level, 4 in the next level. And this forms a triangle, and then it's inscribing a smaller triangle, and there's a big or a small triangle at the top, a bigger triangle in the middle, and then an even bigger triangle at the bottom. For the Pythagoreans, the Tetraktys symbolized the perfection of number and the elements which comprise it. In one sense, it would be proper to say that the Tetraktys symbolize, like the musical scale, a differentiated image of unity. In the case of the Tetraktys, it is an image of unity starting at 1, proceeding through 4 levels of manifestation, and returning to unity 10. So the 10's place, you've moved beyond the first 9 integers, you've moved 1 digit over to 10. And as we spoke before, we were talking about unity being the first number, duality or dyad being the second number, trinity being the third, this reflecting the Hegelian dialectic of thesis, antithesis, synthesis, and then 4 would be the overarching unity of all 3 levels of the dialectic. So unity, universalism, dualism, conflict, strife, synthesis, some sort of compromise, some kind of agreement, some kind of dynamic, some kind of cycle, and then 4 representing the complete system encompassing the Trinitarian nature of the dialectic, being this complete sort of like the 4 corners of the earth is how it's referred to in the Bible. So the Tetraktys sort of represents the, squaring the equation or bringing things to completion from A to B to C to D. That doesn't make sense. A, B, C, D, and then you have a square. That's not exactly how I want to symbolize it. I guess in a triangle you have A, B, C, and then if you bring it to D, you get back to A. So if we're talking about a triangle as the most basic two-dimensional shape, then in order to get back to where you started, you have to make 4 movements, or from A to B is 1 movement, from B to C is a second movement, from C to A is a third movement. So that's only 3. But anyway, 4 apparently is representing the all-encompassing, overarching, perennial, cyclical nature in which we return from a thesis to an antithesis to a synthesis and then back to a thesis again. It's the completed system. Okay? So In the sphere of geometry, 1 represents the point. So a dot, that's 1. It's the most simple thing you can imagine. 2 represents the line, a connection of 2 dots. 3 represents the surface of a triangle, and 4 the tetrahedron. So with 1 point, we get 0-dimensional space. Zeros and ones, off and on, yes or no. With 2, we get a line. So with a line, we can talk about distance, talk about how tall something is, how long something is. We can talk about quantity. The moment that we have a line, the moment that we have 2, the moment we have differentiation, we can talk about one thing in relation to another thing. We can quantify. Then we get to the second dimension, with the line being the first dimension. The second dimension is a plane, the Cartesian plane, x-axis, y-axis. So not only are you able to track distance, but now you're able to track distance over time. So you're able to track velocity, speed, change. The tetrahedron represents the third dimension. Now this is kind of awkward. It's an awkward formulation because we call the third dimension, we say that, well, the second dimension has 2 planes, x and y. The third dimension has 3 planes, x, y, and z. So x being your width, y being your height, and z being your depth. It's kind of awkward because, in a sense, if we're to talk about a point, all or nothing, a single point, it would be easier if we called that the first dimension if we're to recognize that as the monad, oneness, the single point, the first dimension. And then it would make sense if we called the line the second dimension, and the plane the third dimension, and the three-dimensional space that we refer to, the tetrahedron, the polygon, acceleration, change in velocities over time, the physical dimension. If we called this the fourth dimension, that would make a lot more sense, referring back to Pythagoreanism. However, when René Descartes formulated the Cartesian plane, he wasn't referencing Pythagoras directly, and so we do have this confusion that arises. But basically, in the Pythagorean system, the number 4 represents the tetrahedron. It represents the three-dimensional polygons. It represents physical space, and it represents the completeness of the system of dialectic. Hence, in the realm of space, the Tetraktys represent the continuity, linking the dimensionless point with the manifestation of the first body. The figure of the Tetraktys itself also represents the vertical hierarchy of relation between unity and emerging multiplicity. And you should take a look at the Tetraktys. You can see various forms within it. You can see it's a hexagon inside of a triangle. You could say it is 3 triangles surrounding a single point. You could say that it is 3 medium-sized triangles that intersect one another. So this is, we got to crowdsource my whiteboard here so I can draw all these things for you. Although that's going to be hard while keeping perfect posture on the bathroom door. I need like a second camera where I can have like a whiteboard over to the side and I can be drawing on the whiteboard, and then, yeah, I mean, this is a high-tech operation that we need to assemble here. But anyway, to continue, in the realm of music, it will be seen that the Tetraktys also contains the symphonic ratios which underlie the mathematical harmony of the musical scale. 1 to 2, the octave; 2 to 3, the perfect fifth; and 3 to 4, the perfect fourth. Let's see if the footnote explains that. Relating to the musical ratios of the Tetraktys is the Pythagorean saying, "What is the oracle at Delphi?" The answer is the Tetraktys, the very thing which is the harmony of the sirens. Nicomachus of Gerasa also identifies the harmonic ratio of 6, 8, 9, 12 as a version of the Tetraktys in his Manual of Harmonics. Alright, we might further note that the Tetraktys, being a triangular number, is composed of consecutive integers incorporating both the odd and even, whereas square number limited, that's a weird construction, whereas maybe a square number limited is composed of consecutive odd integers, and oblong numbers of consecutive even integers, being indefinite. We talked about that before, square numbers, oblong numbers. Since the universe is composed of peras and aipiron woven together through mathematical harmonia, it is easy to see from these considerations why the Tetraktys, or the decad meaning 10 dots, 10 points, was called cosmos, world order, Oranos, heaven, and Pan, the all. Now, when we look at the decad, or the Tetraktys, we also see what looks like an Illuminati symbol, because it's a big triangle, it's a pyramid, and within the pyramid is a single dot, or an eye. So when you see that symbol, this Illuminati symbol of the pyramid with the eye in the middle, you see it on the United States currency, it's really probably referring back to the decad, probably referring back to the Tetraktys, and probably referring to Pythagoreanism originally. That was later adopted by Freemasons and Illuminati and so on. So, that's an interesting insight here that you don't often hear among the conspiracy theory people. What is next? In Pythagorean thought, the Tetraktys came to represent an inclusive paradigm of the fourfold pattern which underlies different classes of phenomena, as exemplified by THEON of SMYRNA in Appendix 1. Let's see. In Appendix 1, how many Tetraktys are there? By THEON of SMYRNA. The importance of the quaternary obtained by addition, that is to say 1 plus 2 plus 3 plus 4, is great in music because all the consonances are found in it. But it is not only for this reason that all Pythagoreans hold it in high esteem. It is also because it seems to outline the entire nature of the universe. It is for this reason that the formula of their oath was, "I swear by the one who has bestowed the Tetraktys to the coming generation, source of eternal nature, into our souls." The one who bestowed it was Pythagoras, and it has been said that the Tetraktys indeed appears to have been discovered by him. The first quaternary is the one of which we've just spoken. It is formed by the addition of the first 4 numbers. The second is formed by multiplication of even and odd numbers starting from unity. Of these numbers, unity is the first because, as we have said, it is the principle of all the even numbers, the odd numbers, and of all the odd even numbers, and its essence is simple. I don't know what an odd even number is, but next comes 3 numbers from the odd as well as from the even series. They allow for the unification of odd and even because numbers are not only odd or even. For this reason, in multiplication, 2 quaternaries are taken, one even, the other odd, the even in double ratio, the first of the even numbers being 2, which comes from unity double, the odd in triple ratio, the first of the odd numbers being the number 3, which arises from unity being tripled, so that unity is odd and even simultaneously and belongs to both. The third number is the even and double series. In the even and double series is 2, and in the odd and triple is 3. The third of the order of even numbers is 4, and in the odd series 9. The fourth among the even is 8, and among the odd numbers 27. So it looks like we have a triangle here with 1 at the top, 2, 3, 4, 9, 8, 27. So it looks like we are taking 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. On the other side, 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27. So these are squares. The ratios of the most perfect consonances are found in these numbers. Even the tone is included. However, unity contains the principle of ratio of limit and of point. The second numbers 2 and 3 have the same side ratio being prime. In composite numbers, and measured only by the unit. So we were talking before about prime numbers. Prime numbers are now appearing. Measured only by the unit and are consequently linear numbers. The third terms, 4 and 9, have the power, and we're going to have to pause the video